Hey guys. So, first of all, I just wanted to thank all of you who recently subscribed. I've gone from about 100 and something subscribers to almost 600 in the span of less than a week, and that's just incredible. I never expected to get anywhere near that. And yeah, thanks. It's all thanks to you and that zany German who pointed you my way. God knows why he did that, but I am very grateful. Um, so, um, it's Saturday, and as I've grown accustomed to, I went to the flea market, and I didn't find as much as last time. Apparently, my sources are kind of drying up, but I did still find a few interesting things, um, mostly in Soviet technology as usual by now, but a few other interesting things which I don't think many people have seen. So, without further ado, let's get into one of the smaller items on the list today. So, the first thing I found was this very cute little impulse counter. So these things are usually attached to pieces of equipment which have a turn on counter or something like that, or it could be a running hours counter or something like that. This had a Romanian seal or some description. I don't know if you can see for the brightness of the LEDs, but there's a typical Romanian map here, and it's probably off of some equipment which was guided by some laws. So this number probably referred to something that shouldn't have been tampered with because it covered both of the holes that you need to pry at in order to remove the inner workings of the mechanism in order to tamper with it. So you shouldn't be able to basically turn this counter back. So it's as simple as it goes. It's a simple solenoid which drags the first digit up, just up. And when the first digit hits 9, the next the next cycle will actually pull 2 digits with it, so it will turn from a 9 to a 10. Let me just quickly demo that. It seems to work on 12 volts, so 12 volts, and it can go up to a maximum of 15 counts per second. I'm just gonna set the power supply to 12 volts and give it a couple of quick whacks, and we'll see what it does basically. So I'm not gonna connect this other one completely because it won't run. It only takes pulses, so you can see basically that digit going up and incrementing. And it's if you make the same mistake as I did and touch the both terminals at the same time, you'll notice that there's a diode inside that was supposed to prevent the back EMF from spiking the voltage on the output, but it's long dead and it's quite painful, so it gives quite a nasty shock. So I'll take it apart and I'll give you a closer look of the mechanism inside. These things are some of the most satisfying mechanisms you could get to see in the real world, or at least to me. These and those hand clicker things, the tele counters. So I'll take it apart and I'll be right back. Okay, so I've managed to gently pry it open with my pry bar here, and if you yank on it a bit, it's not that easy to get out. You'll see the digits, each digit. So this is a 6-digit counter. So you can go up to 9,999,999. Sorry, 1 less than a million. And we can see actually how the mechanism actually works. So you can actually see that little arm there, uh, moving back and forth, and when you release the power, actually, it increments to the next digit. So when you apply power, it actually gets stuck between digits, and when you release it, it goes to the next digit. And it can actually go pretty fast if you get it like tickling the that connection. You can get it spinning around pretty quickly. But just think about it. So this is 15 counts a second at most, and to get to a million, just gonna plug in the math here of how long that would take. It would take a very long time. So this thing was at around 600,000, almost 700,000, which means that whatever this thing was counting, it had been counting that for a very long time. Okay, let's go to the next item on the list, and I'll be right back. Can you tell that I'm actually kind of reaching for content here, because yeah, today wasn't a very fruitful day, so my gear acquisition syndrome is kind of in withdrawal today, but that's all your fault, guys. So next thing I found was this weird thing. It's made by Showmandel or something like that. Fit mobile tester. This is fast something something, and it was calibrated quite recently. I'm not entirely sure you'll be able to see there, but it's the 25th of March 2015, the last cal date. These weren't included with the package, but what this is basically a 3-in-1 instrument for cable technicians or something like that, or for not necessarily cable technicians, but for people working with RF. So it might be for a GSM base station install or something like that. So it had a head which you'd plug into this weird connector here, and you also had a voltmeter and a resistance meter. So just so you don't lug around a multimeter for like a quick and dirty troubleshoot, seeing if something's open or short, or measuring a couple of voltages or something like that. So it's I'm not sure it can do both at the same time, like measure a voltage and the RF power, but yeah. So this was basically to measure transmitted and reflected power for stuff like tuning antennas or something like that in the RF field. So it's I'm pretty sure that the RF head is basically a diode detector, and it's just measuring the peak, the amplitude of the detected signal with a very simple ADC built into the microcontroller inside this thing. You'll see it. I took the liberty of taking it apart because it was gross and filled with dead batteries. But yeah, you can see that crusty blue color coming from batteries which have been left inside for far too long. It's made in Germany, and yeah, it's pretty interesting. There was a shield beneath here, which you won't see because I took the liberty of taking it apart for more continuity. But so this is the whole thing. So disconnected to the battery terminals, and we can power it on, and I'll show you what it's all about. Infineon 8-bit microcontroller. It's an 80C515A. I think this is the ROM, so the firmware for the thing. A relay, which I assume, so it's got a very interesting power on sequence. So it basically draws absolutely no power while it's turned on. And I think it's doing that via this relay. So when it shuts itself off, this relay disconnects the entire circuit from the battery, so it doesn't have any idle battery draw, because I don't think this is a very low power microcontroller. The whole device draws almost 100 milliamps when the LED backlight for the display is turned on, and it's almost gonna draw like 30 something milliamps when the backlight is off. So older microcontrollers didn't have such good low power performance. And we have a couple of switching regulators here. LM324 quad op amp. I'm pretty sure that this is just the buzzer driver or something like that. This thing is insanely loud. It reminds me of Reps's electrometer and the nightmares he had with that thing. And this is probably some sort of addressing for the basically for the firmware. And we have some input filtering for the voltmeter, and we have a choke and a capacitor for the resistance, and the ground, the common ground. So these three terminals are for the voltmeter and the resistance meter. It only goes up to a kilo ohm, so it can't measure anything very drastic. And these are the connections for the external probe that would hook up in the RF path you are trying to measure. So I don't have that thing, but we can do some more experiments with just this unit. It's built pretty nice. The components on here seem reasonably high quality, so there's no... I very much avoid using the term Chinese components, but you know, let's call them questionable quality components. And yeah, flex cable towards the keypad. There's got to be another display connection here, that row of pins sticking out there, and battery. So it takes 6 volts, and here's me trying not to fry it. Wait for it. It's very loud. And it's even louder when you use the continuity tester, so it's probably not on function right now, but if you can see the display and you hit ohms, it's off the scale right now. So if you short these together, so this is me talking over it, you can tell how loud this thing is. Yeah, and I actually tried to measure I shorted something out there. Anyway, so if I could connect these things at the same time as showing you the screen, this is an 100 ohm resistor and it's showing 98 ohms. So it's pretty close. I haven't measured this resistor to see how far off it is, but I don't have high expectations of a 2-digit, 3-digit display basically. So yeah, voltage is pretty darn close as well. So if you connect just the input to its own power supply, the ground is shared, so it should say 6 volts. And let me do that right here. And yeah, that's very close indeed. And they brag about it having a very sharp response time, so being able to find dips in the power supply you're trying to measure. I don't think this thing was cheap when it first came out, because there's quite a lot of tech packed inside, and it seems to be quite an old device, and squeezing this much technology into a portable thing a few decades ago was quite a feat. And for 6 volts with 2 zeros after it, that's pretty close in my book. Okay, so this is the second thing that I found today. Not very exciting, just a piece of like telecoms installation gear. It's worthless, basically. But so, couldn't resist grabbing it. Maybe I could turn the insides into something else. Or I could just, you know, acknowledge the fact that I have a problem and I'm buying far too much stuff. I didn't need this, but it's interesting. So, and it's got one of those cool sockets for one of those quad no leads. I don't know what this thing is called, but it's a quad QFP package, but socketed. I always enjoyed these. Okay, let's get to the next thing on today's list. And fair warning, I did butcher this thing a bit. and I'm trying not to let it rest itself onto the um, onto my mouse pad here, which is kind of dirty, but because I've tried to desolder two of these things in order to give you a closer look. So what this is I have no idea. These are all 4-digit displays, and they're probably daisy chained or something like that, so they can display individual readings for something. I assume that it was temperature, because there was a temperature indicator around here. So it could show you the temperature of several zones or something like that. I have no idea what it was from, what it is from, where it came from. You can see the part numbers for the displays here. The integrated circuits here being starting with a K and having Cyrillic letters indicate that this is Soviet. And I'm pretty sure, yeah, this is Soviet technology, Russian, something like that. But the interesting thing that caught my eye was the display technology. It's pretty cute. So there's 4 matrices of LEDs inside each of these red things, and there's quite a lot of them. I don't know exactly how many, but because I didn't count them, but there's quite a lot of them, and they're individually multiplexed inside. There's a chip that does the multiplexing. So there's 4 multiplexed chips arrays inside one of these things, and there used to be 2, 4, 6, 8 arrays multiplexed on this board. So it could show quite a lot of digits. I'm not sure yet again what it was used for, but a lot of digits. And I assume that these displays are terrible to look at because the digits are very small, and I think they're quite dim. But they would have been pretty high tech when they first appeared, I think. So after heartlessly butchering one of these things, this is what it looks like inside. So as I said, let me grab a pointy thing. So this thing right here is a die which shoots basically into this PCB. It's a pretty thick PCB with some vias, and it multiplexes this array of LEDs. So there's 1, 2, 3, 4, 5 times, I think, 8 or 7, so 35, 40 LEDs in one character. And it can do, I'm pretty sure it can do individually, like you can turn on any LED or off, so you can have not only numbers but also characters, because otherwise if there were only numbers you'd just use 7-segment displays. But these are very fancy, and I'm gonna insert some photos from underneath the microscope and show you how they're done. Basically, one row of LEDs is connected to one of these pads here, one of these traces here, and the columns are connected to these connections here, to these pads here. And applying power to any combination of row and column lights up one of the LEDs. Let me see if I can actually get you in a little closer and focus. And I'm going to try and put the multimeter probes onto a couple of the connections and try and light an LED up for you guys and explain why they would be so terribly small and hard to see. I think you could just barely see it. And yeah, here it is moving up and down. Let me turn off the light actually for a second so you can see it better. Yeah, and you see it moving around? So the way it does it is basically it shifts the LED you're trying to drive. That's how multiplexing works. You try and turn this on, turn this LED very briefly on, and then turn the next one you need on very briefly. And the persistence of vision that the human eyes have actually contributes to a coherent image being formed in your mind, in your brain, basically. So yeah, very cute. Lots of bond wires. So all the dies are bonded between like one row, and the columns are one of them is the anode, one of the columns is the cathode, I think. So yeah, and you can see the vias going from the small dies, the control dies, shooting into the PCB and making their way somewhere else. I think to here and here. So yeah, that's basically it. I'm not sure the die itself does a lot. It might just be some of the transistors that are required in multiplexing, but what's certain is that you're gonna see a bit more detail when I put these under the microscope. Okay, I'll insert this and leave you with some text, and then we'll go to the next piece that I found today. Okay, so a quick demo for the, whichever this is, the fourth thing I found. It's just a moving needle micramp meter, but it's very small. It's kind of one of the smallest movements I've ever seen for a reasonably sensitive. So this is 200 micramps for full-scale deflection. So if I turn on the power supply, which has a 10K in series, you'll see that 10K, 1 volt over 10K is basically 100 micramps. This thing's a bit off, but come on, look at it. It's so small and so Russian and so old. It's probably from some sort of industrial piece of equipment or apparatus or something like that. And no, it doesn't have any radium. It doesn't glow. It's safe. I checked it. If you ever see stuff like the backs of these indicators, the thing behind the needle, and it looks like a yellowish, sickly yellowish paint, and it's from Soviet equipment, especially from military equipment. Those used to have radium, like the radium watches on the watch hands on watches. The radium was actually so hot in those things that some of them are crazy. There's a video by a friend of mine, especially about the DP63 dosimeter that the Russians had. So the DP63 was what I would like to call a how dead you are meter. It had 2 ranges, I think 5 roentgens an hour and 50 roentgens an hour, and both of them are like unsurvivable levels of radiation for any human. So it was made for contamination surveillance immediately after a nuclear fallout event or something like a nuclear disaster like Chernobyl. So funny thing is that because they were aware of the fact that nobody was gonna survive going there, I think somebody executively took a decision of saying like, oh yeah, let's make them at least visible. So they slathered on a whole load of radium paint on the dial, and they can go up to millisieverts of dose right at the window. So those are crazy radioactive. I wouldn't advise any of you to go anywhere near those things unless you have a death wish or something. Moreover, usually a Geiger counter, like a Geiger counter probe, like this one I had last time, these things usually count pulses. Like every interaction with a radioactive particle is in impulse, like as I've shown you, and this means that there's no continuous current flowing through the tube. That means it's operating as a open circuit until it gets ionized by a particle. There's an avalanche breakdown inside, it shorts, and it registers as a pulse, right? Not for those. Those were always biased. They had a small continuous current running through them, and depending on the amount of radiation they were surrounded by, the current would increase or decrease due to the ionizing radiation. So those things were really insensitive. The tubes inside them were like extremely small glass tubes with very small anodes and cathodes, and I'll insert a few pictures if I can find any of them. And the way you set the zero on them was even crazier. So last bit of trivia for today about Soviet Geiger counters. Then you can go watch my friend's video about that particular model. It had a strontium-90 source inside, which you would flick a window open, so the radiation from the strontium would hit one of the Geiger-Müller tubes, and you'd set the potentiometer on the front of the device to 0. That's how you adjusted the scale, basically, the offset of the the Geiger counter. It was really stupid and made for like desperate attempts, last-ditch efforts. We're all gonna die sort of situation. So let's see just how bad the fallout is in the zone, and we don't care about how many people we're gonna send to their deaths. Basically, that was the thing. They would, if anybody had to go trekking around with one of those things and measuring the food or the soil or anything like that, and it would show any significant readings, that's it, you're gone. So yeah, how dead you are meters. That's what I like to call them, and hopefully we'll never have to use any of those things as from a nuclear catastrophe. Okay, in lighter terms, I actually have the smaller brother of that DP63, and this is a sufficiently good segue in order to show you that thing. I didn't find it at the flea market. Another friend of mine got it for me a while back from the Ukraine. While there was no special military operation there. So I'll be right back with that thing and I'll show it to you, and I'll tell you a bit about what I did to make it work again. What? Don't have a Geiger counter? Well, I have about 5 of them, and I don't have a problem. You have a problem. Okay, so this is the DP5. DP5B actually. This is one I got from my friend Stan. I got it from him because I just wanted one of these things. It looks very cool. This is one of the actually one of the Geiger counters which was featured in not this particular unit, but this model was featured in the show Chernobyl from HBO. So what we have is a very simple device. This means off. This means regime. Regime. Basically, it's tuning, and you're supposed to adjust this potentiometer here until that needle points to that spot right there on the dial. And then you have 200 roentgens an hour, 1,000 microroentgens an hour, 110, etc. So for 200 roentgens an hour, you look on the bottom scale. For the smaller scales, you look on the top scale and multiply by whatever it says on the dial. This is also a how dead you are meter. And it's fascinating because it works on exactly the same principle, but it doesn't have that stupid radioactive source to set the current for the 200 Roentgen range. And how it does, what it does is, for the lower ranges, it actually has an SBM10 tube inside. You can actually see it through this window here. For the higher ranges, it does the same trick with the current. But as I've been through here before, I can actually unscrew this and show you what's inside, because it's actually quite fascinating. So what we have here is one of the Geiger counter tubes and the other. This is the precursor to the SBM20, the STS5. So this Geiger counter tube evolved into this one sometime later. They're perfectly interchangeable. They almost look exactly the same. This one is just an updated version of the older one. So this is the inside of the probe, and these are 2 thriathrons, or whatever how they're pronounced. These actually take the pulse from the Geiger tube and turn it into a very short-shaped pulse, which goes to the integrator circuit inside here to basically show dose. It's not energy compensated or anything like that, but it works well enough and it was reasonably accurate from what I remember testing it last time, just comparing to background radiation. So give me just a second, because I have to show you these two tubes lit up and flashing when this one detects some background radiation. So what I've done here, and you can't really see it because it's kind of hard to fiddle around with all the wires and stuff, is I've hooked up 3 volts from my external power supply, brought in my trusty uranium glass, shot glass and marbles, and I've tuned the circuit so that you can actually see some radiation. You have to set the stabilizer voltage at the beginning using that knob I showed you in front. So every pulse, every flash of light that you can see is actually one of the impulses basically generated by the Geiger counter tube when it detects a particle, either beta or gamma. And you can see that the theriodons, or whatever, they're hydrogen triodes. They trigger and they flash, and it's very, very interesting. I find this fascinating. Like, look at it, how nice and glowy inside it is. Let me zoom you in a bit closer, and you can see them better. So you can see there's a filament, I think, inside, or yeah, and there's a steady discharge, the blue glow, and when actually, sorry, the blue glow is just a reflection. These are the steady discharges, the orange glow you see right there, and when a pulse happens, it ionizes the entire volume of gas inside, and it shorts basically the anode and the cathode. That's how these things kind of work. They work like triodes, but they don't have any of the linear region. They're just either on or off. And yeah, that's about it. I hope I haven't gone too far astray, but I had to show you these things. They're really cool, and they're very nuclear proof, so they're not very rugged, but nuclear proof. That's why they put them in this giant enclosure. Yeah, so that's it. I'm gonna go to the last item of the day, because we're already kind of stretching the limits of what I would expect you to watch. So I'll be right back. So imagine the look on my face when I walk into the flea market this morning and one of my regular drug dealers has this on display. Like, the first thing I looked at it and I was thinking, this is a grenade, a valve, whatever the hell this thing might be. Anyway, it's very heavy. It's exceedingly well built. And if you take a look, it's actually a temperature transmitter. It's a 4 to 20 milliamp thing output temperature transmitter, and it works with both PT100 in 2, 3, or 4 wire measurements, or 2 thermocouples, or 2 thermistors, or a load of different configurations. So it's made for being put in explosive environments. It's fully sealed. It's built like a tank, and it's got a lot of threads. And it used to cost about $1,600 when it was new. Don't ask me where this guy finds them. I have no idea. Probably from decommissioned equipment. But this one looks like absolutely brand new. It's insane. The cleanliness inside. This is my addition. So you can see it's a model 3144P temperature transmitter. So we have 2-wire, 3-wire, and 4-wire RTD calibrated for PT100 sensors. 1 thermocouple, 2 thermocouples, and actually can go to 2 3-wire PT100s. And it runs on basically 12 to 40 something volts. And I'll show you the rest of it right now. So inside here we have some beefy, these are, I think, nickel plated contacts. That's not entirely correct for thermocouple applications, so you'd be better off using a PT100 type sensor due to the thermal EMF and stuff like that. So this is negative positive, and I have no idea. This might be the 4 to 20 milliamp output. I haven't tested it. I only saw that there is a freaking display on the other side, and that's what hooked me. So I had to chuck this in the lathe and literally chuck it in the 3-jaw chuck in order to get enough purchase on it to take it apart. It was very, very tight, and I didn't manage to mar it up too bad, so it's pretty clean still. You can see a bit of a mark from where the jaw bit on the paint, but it's so thick that I don't think it will actually it did anything to it. So what we see inside is an LCD display, and I'll first power it on and show you what it does. With that, it's around 100 and something ohms right now, the potentiometer set, so it can show a temperature. Otherwise it lights up an error and says that there's no sensor. So I'm gonna connect the power supply to it and set it to around 15 volts, and we'll go positive and negative. This one hasn't got any beepers, and you can see the LCD pops up, and you have a lot of different options. First of all, it has a very nice bar graph, and we can wait for it, and it'll say 46 point something degrees. It actually goes to millikelvin, which is very nice, millidegrees centigrade or something like that. And yeah, what this thing is, it's a very robust thermometer, and I was gonna take it all apart and show you what's inside, and I'm still gonna do that, but fair warning, it's gonna be very disappointing. So you'd expect this thing to cost an arm and a leg, of course, be very robust. I think it could be used as a blunt force trauma implement. Like, you could very easily kill somebody if you hit them over the head with this. So industrial applications require very strong construction. This would be a very nice enclosure for something that needs to be explosion proof, impact proof, bulletproof, whatever. The glass itself is at least 4 millimeters thick. Like, it's very, very thick. Okay, so I'm gonna disconnect it. Oh, by the way, it's pulling about 5 or something milliamps from the power supply, so I don't think this was meant to ever run on batteries, because it's continuously pulling about 5 milliamps. I think this was meant to be installed somewhere, and where it has power and where it can talk back to a base station through wires. There is a model of this series of rose mount devices from the same guys as last time's device that has the same looking transmitter. So I'm assuming that you could get these in a more energy efficient format with the same MSP430 inside. And it has the same looking antenna, so they could also be used in remote applications. This is why I also believe that the back is so easily detachable, like no screws or anything, just a very tight thread and an O-ring. So you could potentially go in and replace batteries as you need. So let's take out some screws. I have my trusty screwdrivers here. By the way, anybody have any complaints about the very long form of the content? I usually know that, at least for me, attention span is a problem. But I've seen that these videos were quite popular. So thanks to the subscribers Marco sent my way, I think most of the people quite enjoyed it. If you didn't, please let me know what I can do to make the content more palatable. So what we got here is an Oki display driver. This is basically just the display driver for the display behind. And you can see that it can be mounted in several orientations according to your needs. So if you need to have it like this, upside down, you can just swap and the display itself inside and just switch the screws to different holes accordingly. and you can have it facing any way, so you don't have to do weird things with your head, like when you play a weird noise your dog doesn't understand. So and this is where this disappointment begins, because I should have seen this coming, but this thing is absolutely completely potted. So I don't even know why I'm taking it apart, but so you believe me, there's just two user accessible switches and that contact there for the LCD, and that's it, nothing else. And this is the module that is responsible for everything. So wah, 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 it's potted. It might be silicon, and I might be able to pry it apart, make it more educationally friendly, but this will take a while. Let me get back to you on that. God damn, the liberal application of percussive maintenance did nothing to this thing. Okay, so I tried IPA. IPA did nothing to it. I don't have any acetone on hand, and I'm not really willing to invest any more effort into tearing this thing apart. So what we can see is a Netmega 128 from the time when Microchip didn't yet buy Atmel. This was actually in the first generation of Arduinos, I think, the 2009, I think. So yeah, we can see some SMD components, some capacitors. There's an interesting transformer here. I don't know what's wrong, why it's needed. Probably something for power supply, because it can accept anywhere from 12 to 40 something volts. I'm assuming it's got a switching regulator to drop it down to whatever this thing needs, 3.3 volts or something like that. And just using a, it might even be an inductor, I'm not sure. It looks like a transformer. So probably it's got a, what do you need for measuring a PT100 or a thermocouple? So for the thermocouple, you need a thermocouple amplifier. So a thermocouple amplifier basically takes the small voltage a thermocouple outputs proportional to the temperature and amplifies it, and it would then feed it into the ADC of this microcontroller. I would assume it's not actually directly feeding it to the ADC, because the ADC in these things are usually only 8-bit, 10-bit, something like that. Yeah, 10-bit, 1024 basically levels. So we could see that there were actually millikelvin resolution, which would imply much higher resolution than that. So it's probably also got a discrete ADC somewhere around here. Try to dig around for more ICs, but some of them seem to be either filed off or etched off or something along those lines, because I couldn't read any part numbers on two of the ICs I found. So for a thermocouple, we've settled the debate. So thermocouple amplifier and ADC. What do you need for a PT100? For 2 wires and 4 wires, it's kind of the same thing, but there's a bit of a technicality and difference. So for 2 wires, you need a current source and a voltmeter, basically. So you inject a known current, usually a couple hundred microamps or a milliamp, through the PT100, and then you read the voltage across it and do Ohm's law. And and you do it on 2 terminals. That's the caveat in the whole thing, because when you're doing that, you're also measuring not only the resistance of the PT100, which is the actual sensor, basically the resistance variation with temperature is what indicates your basically your temperature. You're also measuring the wires to the PT100. If you measure it in 4 wires, you inject current through 2 of the terminals and measuring voltage on the other 2 terminals, and you're ignoring basically the resistance of the leads going to the PT100. That's why my Prema actually has both 2 and 4 wire configurations for PT100, so you can do what's called a Kelvin measurement. So what I'm left with is a mess. Look at the things I do for you guys. Like, look at this. It's gonna take ages to clean. But anyway, in the end, it's not all bad, because what we have is a very, very rugged enclosure, explosion-proof even. So these are actually made so that if you put them in an environment which can have explosive gases or mixtures in the air, it will not trigger an explosion. There's no sparking that can make it out. And we have a very cute LCD, which we could probably figure out the pinout for this microcontroller, or actually display driver, and we could talk to it. I was actually thinking of making this into an actual thermometer with a battery built in and everything, so it would be a cool set piece that the cats can kick off the shelf that I put it on and then dig a giant hole in my flooring. So yeah, so what do you think? Thermometer, PT100 thermometer in baby blue Thomas the Tank Engine-ish color enclosure? Let me know in the comments. Anyway, I'm gonna go clean this mess up, put the IPA, dispose of it safely, and thank you for watching. I hope next week's gonna be a bit more interesting. In the meantime, I'm gonna try and put out a video tomorrow about a different thing that I found not at the flea market, but on eBay, because I told you, gear acquisition syndrome is going completely off the rails for me. It's in the same family as the Keithley source meter I showed in the power supply video, but it's at least 4 times as awesome, and yeah, you'll see about it. Hopefully tomorrow, but no promises yet. And please leave some video ideas you might be interested in doing and seeing, considering the fact that the channel has no clear definition so far, so I can spread into a bunch of areas, but I'm interested in what you guys have to say and what you guys would like to see. So we can do basically quite a lot of things. So I'm one of the lucky few who have accrued a significant amount of test equipment, and I'm aching to show it off and tell other people about how awesome the world of electronics is. Anyway, I don't have any jokes for you today. It's been terribly hot, and